Hi, my name is Irene Michel Muñoz Garza, and I will present my argumentative oral exam. My first question is about mention some advantage and disadvantage of different types of separation techniques for the extraction of beta-glucans from brewer suspended yeast. There are different separation techniques, but I will talk about three: filtration, centrifugation, and chromatography. Filtration is used to separate insoluble solid from liquid. Centrifugation is the technique that used to separate particles based on their size, shape, density, and viscosity, and chromatography separates components based on their properties such as polarity, charge, or size. First, it's important to mention that these three separation techniques are present in different stages of the process. For example, the filtration is present in the primary recovery stage, and the centrifugation is present in the intermediate and the primary recovery stage. But, for example, the chromatography is only present in the purification stage. So they have different purpose. They are not for the same thing. There are different separation techniques, but not used for the same separations. And well, we have the advantage and disadvantage. First, in the filtration, we can see that it's simple, it's cost effective, it can be used to obtain a product that is free from unreacted chemicals, byproducts, or contaminants. It's efficient to separate solids from liquids, and some disadvantages are that it's not suitable for separating small particles. It's difficult to scale it. It is a primary recovery of biomolecular technique, is limited throughput capacity, has low selectivity, raw processing conditions, and it needs a labor-intensive techniques. For the centrifugation, we can see that it's fast, it's efficient, it has high yield and purity, it's low cost, it removes impurities from the extract beta-glucans, and it can be scaled to industry, for example, the disc stack. Some disadvantages are that it's not suitable for large volume of samples, is long process, has a high energy demand, also limits throughput capacity. It has low selectivity, road processing conditions, and labor-intensive techniques. And for the chromatography, we can see that it has a high purity of the desired byproduct. It is the gold standard, has a high selectivity, has many variants, and high purity, is efficient and well tested. But some disadvantages are that it's expensive, high time consuming, need to specialized equipment and trained personnel. It has high operational costs. It can be scaled and is not suitable for large volume of samples. My second question is to explain which parameters must be considered to dimension one of my team's unit operations. And I will talk about the scaling of the spray dryer. First, a report laboratory scale methodology was used, which allow us to select optimal operating conditions. In this case, the inlet and outlet air temperature, the flow of compressed air of 70 liters per hour, and a sparking velocity of 0.25 liters per hour, and considering a content of solids of 8% of the extract before drying. One key variable of sizing of spray dryers that needs to be considered is the residence time, which can be described as the chamber volume divided by the total airflow rate. The retention time for laboratory scale process can be calculated considering the dimensions of the equipment they use. So we first calculate the volume, that in this case is 215.9 liters, and with this volume we can calculate the retention time, dividing it in the total airflow rate. In this case, 700 liters per hour. We calculate a retention time of 18.22 minutes. Then, taking also in consideration the relation of the sparking velocity flow air, the characteristics of the industrial pilot scale spray dryers can be known. First, the volume of the spray dryer can be calculated with the corresponding dimensions. We obtain a volume of 127.79 liters, and then the required flow air can be calculated by the chamber volume divided by the time of residence, and we obtain an airflow for the industrial pilot scale spray dryer of 3,347 liters per hour. With the correlation of the sparking velocity between the flow air equals to 0.000357, the actual sparking flow of the sample needs to be 1.19 liters per hour. However, these conditions were considered for an old and inefficient equipment. Considering an actual new and efficient equipment capable of manning a sparking flow up to 200 liters per hour, the sparking flow can be modified to be 70 liters per hour. With this final sparking flow, and considering that from the initial biomass treat of the process of extraction of beta-glucans of 83.3 kilograms per day, the extract of beta-glucans obtained corresponds to 15.91% of the yeast biomass. In addition, a ratio between the wet weight of beta-glucan and solvent volume of 1 to 4 is required to be introduced in the spray dryer. With this, it can be inferred that the actual volume introduced per day in the spray dryer is approximately 53 liters. So the required time in this polishing process of extract beta-glucans by spray drying per day is approximately 45 minutes. And this is the commercial spray dryer that we choose to propose under the conditions that are present here, that are a sparking flow of 70 liters per hour, an airflow of 3,347, a temperature of 146 Celsius degrees. The material is stainless steel, and while the actual volume introduced per day is approximately 53 liters. And the time required in this polishing process is approximately 45 minutes. And my last question is, did you propose unit operations that were not selected for the final process, and why were not selected? The previous bioprocess protocol had the steps of dewatering with sodium hydroxide, centrifugation, autolysis, high pressure homogenization, use of isopropanol as an organic solvent for the elimination of lipids in the cell wall, and a treatment with protease for the destruction of complex monoproteins. But for the final proposal of this process, the stages of autolysis, organic solvent, and the treatment with protease were modified. Next, I will present the reasons why these unit operations were not selected for our process. First, the extraction of beta-glucans autolysis is used to release the beta-glucans from the cell walls of yeast. However, this autolysis can also release other unwanted compounds that can affect the quality of the final products. In addition, autolysis can be costly and a slow process. It can take several days or even weeks. It has a loss of sample integrity because can cause the sample to disintegrate and lose its integrity, making it difficult to analyze and can affect the accuracy of the results. Also, an important factor is the contamination because the autolysis can promote bacterial growth and sample contamination, which can affect the results and the interpretation of the data. It causes interference with other processes, such as protein or DNA extraction, also which can affect the results of interpretation of the data. And it's difficult to controlling the process because autolysis is a natural occurring process that is difficult to control, which can affect the reproducibility of the results. And about the organic solvents, the main disadvantage of using them for the extraction of beta-glucans are related to the high cost of organic solvent, such as NXN, and the contamination resulting from this emission of solvent vapors into the atmosphere, which is subject to a strict environmental regulation. The use of the organic solvent can also lead to the formation of toxic bioproducts. Other disadvantages are that it has a large amount of extract waste, the extraction is limited, extract and difficult to automate, and the temperature gradient heating. And about the protease treatment, since the protease treatment was no longer necessary as part of the protocol, it was decided to discard this step and up to a different methodology. As I mentioned before, this new protocol uses high pressure homogenization as the lysis method and one step alkali extraction assisted by high pressure from a fermenter to optimize the time and the yield of the process. However, there are areas of improvement in the project. One of these are definitely to our purification step, like filtration that allowed us to filter or get rid of contaminants and unwanted compounds and increase the purity of our product.